Class, today we're going to talk about strategies to solve multiplication problems. As with other math topics, there are several, multiple, pun intended, strategies that we can use. But first, let's start by saying this. What is multiplication? Lamar? It's like when you add, you just keep adding, you keep adding, you keep adding. It's like you just do it over and over again. Yes, repeated addition. Listen, that brings up my favorite movie. I know some of you all are too young to remember the movie, but it's called Multiplicity. It was a father really trying to figure out how he can fulfill all of his duties as a dad. So he added versions of himself. Repeated addition. So he did it several times till he had a house full of himself and he was able to fulfill all chores. Please go and watch it. So now I want you all to discuss ways that you already know how to solve multiplication problems. Let's see, I'll call London. How do you know how to solve the standard algorithm? Well, obviously it's the easiest one. The standard algorithm. Can you show us that on your whiteboard? I just multiply the 5 times the 2, which is 10. I carry my 1. 1 times 2 is 2 plus 1 is 3. Now I put my imaginary 0. And 5 times 1 is 5. And 1 times 1 is 1. And so I add it and I get 180. So 15 times 12 is obviously 180. London, that was amazing. Anyone else? Anyone else know a different strategy? Oh, everyone's shy today. April. No? You were going to say standard algorithm as well? That is fine. What about you, Christian? The area model. The area model. We're going to take a look at that right now. We're going to let you be the teacher. I like this method because I like to draw, make my box. So 15 is 10 plus 5, and 12 is 10 plus 2. Now I just fill in the box. 10 times 10 is 100. 10 times 5 is 50. 2 times 10 is 20. And 2 times 5 is 10. And now add them all up. That's 100, 150, 170, 180. Got the same answer as you, London. We don't cry, we multiply. Excellent job, Christian. I really appreciate your input. One last one. Anyone else? Anyone else want to share their strategies? Jaden, you're ready. What you got, Jaden? The method of doubling and halving. Class, did you all hear that? He said he learned how to multiply using the method of doubling and halving. We have to see this, right, class? Let's see it. See, these big numbers, I can change them. So I gotta do half of one and double another. So I'm gonna take half of 12 and I'm gonna get 6, but I'm gonna double 15, which is 30. Now I could do that real quick, but I'm gonna take half again of 6, which is 3, and I'm gonna double 30, which is 60. And I know either one of these I can do 60 times 3. I just do 6 times 3, and I know I have a multiple of 10, so it's 180. Bet you can't do it like me. Jaden, that was amazing. London, Christian, you all were fantastic as you shared, but we have something special today. So first, I want to kind of reiterate what everyone said. We're going to take a look at something different. So I heard standard algorithm. I heard the area model. I heard doubling and halving. But we see a question mark. So, class, this is what I want you all to do. In any one of the 3 methods, I want you to solve this next problem. I'll give you all a few minutes to work together or independently if you really want to challenge yourself to solve, and we'll come back as a class and discuss how you solved it. Class, I saw some great work. I saw different strategies. I wasn't necessarily checking for the correct answer, but let's cover that now. Did everyone get 2021? Excellent job. Standard algorithm, area model, the method of doubling or halving. Either method that you do, you should get the correct answer. What's your question? I wrote the answer down. Which method did I use? Did you see me write it down? I know I made this PowerPoint, so I already knew the answer. So I want to challenge you all. I want you all to give me some numbers. And I'm going to do the problem on the board, and you can verify it with your method. So let's try it. Jessica, give me a number between 1 and 9. 6. Okay, I'll write a 6. April, you can share now. What do you want to say? 2. Okay, I'll put a 2. All right, anyone else? Carlos, what do you think? 6 is already picked, but we can pick 6 again. There's nothing wrong with that. And one last person. Pamela, what do you say? 8. So class, our multiplication problem is 62 times 68. I want you all to do it now, and I'm going to do it on the board. As you all are working, I've written down the answer. So I want you to think about that. If you're in a math competition and you're in a hurry to solve the problem, what in the world did Mr. Christian just do to solve this problem so quickly? Is he a human calculator? Am I? I'd like to think I am. But I'm here today to show you all that there's another way we can do this. And it's really through the use of patterns to solve multiplication problems. So let's quickly discuss what I did in order to solve 47 times 43. And we also did 62 times 68. Class, let's take a look at these two problems. We'll first look at the first one on the PowerPoint, 47 times 43. What do you notice about the problem? That's correct. The tens digit is the same number. So in this particular problem, the tens digit is a 4. So there's a 4 in the tens place for both of these numbers. All right, we've talked about the tens digit. I wonder what happens with the ones digit. Anyone else? What do you think? That's interesting. So you say the ones digit add up to 10. Let's see if that applies to the problem that you all helped me create. In 62 times 68, is the number in the tens place the same? It is. It's 6. Let's check the ones place. Do the digits in the ones place add up to 10? They do. So I'm here to now share an amazing strategy that can help you when you solve these problems. Let's take a look at the answer. So we're going to try this pattern. What is 7 times 3? Do you see that in the answer? Yes, you do. 21. But look at the first two digits. It's a 2 and a 0. How could I possibly get that from a 4? And if you're confused, look at the second problem and say 2 times 8 is 16. But how could I get 42 if the tens place has a 6. So you should be able to look at both of these and determine. I'll give you some think time. Oh, Randy, you're pretty quick. Got your hand raised already. You want to share with the class what you think? Class, did you all hear that? He said he doesn't know if he's correct, but he notices that 4 times 5 is 20 and 6 times 7 is 42. So he figures that we're taking this number in the tens place and multiplying it by the number that comes right after it. So 4 times 5 is 20 and 6 times 7 is 42. Let's see if that works on another problem. That's the best way to test if a pattern applies all the time. So let's come up with another problem, and I'll make it up this time. So class, what we're going to do is do it our quick way, and we're going to check our work, and I'll even have someone break out a calculator. Let's take out that human-made calculator to see if it's actually correct. So who wants to take a stab at getting the right answer using the pattern? What do you think, London? Class, I'm going to write down London's answer. Let's see if it is correct. Is that what you all got? You checked it with the calculator, correct? It is 7,224. How did we know we could use this rule? You have to check 2 things that must be true. The digits in the tens place is the same, and the ones digit added to 10, you can use a shortcut. 6 times 4 is 24. What comes after 8? 9. 8 times 9 is 72, so the answer is 7,224. So class, we're leaving today with a new strategy in our tool belt. So I challenge you all to take it home to your parents to show them that you learned something exciting about another way to multiply 2-digit numbers. All right, I'm going to challenge you as soon as you walk in tomorrow morning. I'm going to ask you, hey, what's this answer? And you should be able to quickly tell me what that answer is, okay? All right, so let's actually take out our Chromebooks, and we're actually going to jump on during personalized learning so that you can actually work on your area of need. All right, let's do it.